Okay. So see, we have started with organ pipe. So we had seen open organ pipe yesterday. So see, regarding pipes, frequency was given by NV divided by 2L. And in terms of Laplace correction, it was under root gamma P by rho. So see, first harmonic or fundamental node. This was given by, when we put n equal to 1, we'll get the value of lambda and the value of the length of the wave. Then we had seen second harmonic, which means the first overtone, and that is twice the fundamental frequency. Now see, we have closed organ pipe. Closed organ pipe means, see, open organ pipe was like this. If I put a boundary over this side, reflection will occur at this end also. Waves will travel like this. So this makes it a closed organ pipe. If you remember, we had seen yesterday open organ pipe like this. See, this was open at both the ends. That's why we were able to observe antinodes at this side. Whereas in this case, this part will give you node, this will give you antinode, this will give you node. Had it been an open organ pipe, it would have been like this. So would we get an antinode over here or a node over this side?
Antinode.
Antinode. This is the difference that comes when you put a boundary. Now see, rest of the term remains the same, just the difference comes in the wavelength and the calculation of the frequency. So see, the formula for the wavelength says 4L divided by 2n minus 1, where n is equal to 1, 2, 3, 4, and so on. Whereas in this frequency, this wavelength was given by simply by 2L divided by lambda. In case of closed organ pipe, it is 4L divided by 2n minus 1 lambda. So we can keep on putting the values of n. If we put n equal to 1, it will be 4. Then n equals to 2, it will be 4L by 3, and so on. And the frequencies formula is under, and we can also write velocity in this case. This is 2n minus 1 divided by 4L. And in terms of this velocity, we can add velocity. And what is velocity? That is under root gamma P by rho. So comparison with open organ pipe. Open organ pipe's frequency was what? NV divided simply by 2L. Whereas the frequency in case of closed organ pipe, this becomes 2n minus 1 and 4L is there in the denominator. This is the difference which comes in case of closed organ pipe. Now see, this was the general. If we put different values, like for the first harmonic. So first harmonic is also known as the fundamental frequency. So when we'll put n equals to 1, n equals to 1 will be there for the first harmonic or the fundament. So this will be 4L and length will be 1/4 of the wavelength. Whereas in the first case, that was the open organ pipe, length was half of wavelength, lambda 1 by 2. So in case of first harmonic or fundamental frequency, regarding the closed organ pipe, this is 1/4 of the first wavelength. So it will be like this. This gives us node, this gives us antinode. This is the first wave. This boundary represents that it's a closed organ pipe, closed at one end. Then frequency for the first one, for the first mode of vibration, this will be 2 into 1 minus 1 by 4L under root gamma P by rho. That is 1 by 4L into velocity. So mu 1 will be V divided by 4L. Then comes the first overtone. So first overtone is for which harmonic frequency? N equals to 1 or n equals to 2? 2. If I say the third overtone, then what should be the value of n? 4. Yes. Because it starts from the second. From the second one, we get the first overtone. So if we put n equal to 1, then we'll be getting 4L by 3 and length of the wave will be 3 lambda divided by 4 in this. So we'll be getting a node over this side, another node over here, then antinodes at this place. Just the reverse of this. N equals to 2, in case of this open organ pipe. We were getting one antinode over this side and one antinode over this side again, two-way. But since we have closed this part, we are not able to obtain these much. This was the second one. This. So in case of closed organ pipe, we are able to observe two nodes over this side and two antinodes over this. So frequency will be 3 divided by 4L, 3V by 4L. Nu2 will be 3V by 4L. So is this clear? Difference between open organ pipe, closed organ pipe?
Yes, ma'am.
So as you will keep on increasing the value of n, you can put it in the general formula for wavelength and the frequency, and you can get the respective values for any overtone and any mode of vibration you wish. Just note it till this part. Then we'll do questions today.
Ma'am, can you school? Done, ma'am.
Okay, now let's do some numericals. Okay, see, it says that a pipe 30 centimeter long. This is open at both the ends. So it means what kind of pipe is this?
Open organ pipe.
Open organ pipe. So it says which harmonic mode of pipe is resonatingly excited by 1.1 kilohertz source. So according to the unit also you can identify that this is the frequency. It says will resonance with the same source be observed if one pipe is closed. Now let's see. First we have to identify for which harmonic mode will an open organ pipe of the length 30 centimeter be giving us the frequency 1.1 kilohertz. So see, for an open organ pipe. For an open organ pipe, the frequency for nth is given by nv divided by 2l, right?
Yes.
Okay. See, we are not aware of this n, but we know the velocity, that is the speed of the sound. We know the length of the tube. We know the frequency also. So what is unknown? Only this term is unknown. So we can find out n using this 2l multiplied by the frequency divided by the velocity. So see, on putting all the values, 2 into length of the tube is 30 centimeters. So we should convert it into meters. And what is the frequency?
1.1.
1.1 what?
Kilohertz.
So should I write 1.1 only?
10 raised to minus 3.
Not minus 3, 10 to the power plus 3.
Okay.
Okay, we are not converting hertz into kilohertz. We are converting kilohertz. It will be 10 to the power. Then the speed of sound is 330. So this will be 3 into 11. And this can be given by, this is given by 0.1. So by this, we can have 10 to the power minus 1. This will be 10 to the power minus 3 and 10 to the power plus 3. So this gives 2 only. So n is equal to 2. So is the first part clear?
Yes, ma'am.
Okay, length was given to us, frequency was given to us, and it asked, and the speed of sound you should remember. Many a times this is given and many times it is omitted. So whenever it is omitted, you should remember this value. Otherwise, if it has to specify, it will give it, whether it's 320, whether it's 330, sometimes it writes 315. So you should remember the value just now. Now see, now it says, will it resonate if one pipe is closed? Now see, if one pipe is closed, this has been turned into a closed organ pipe. Now see, we have just seen it for the closed organ pipe. The frequency for nth term for the closed organ pipe is given by what? 2n minus 1 divided by 4l into the velocity. Now see, the frequency, we have to see whether are we getting an integral value or not. So for that, we have to just try it and find out the value of n that will be coming for a closed organ pipe. We have seen it for the open organ pipe. For the open organ pipe, it is what? N is equal to 2. But we don't know if it's n equal to 2 for closed organ pipe or not. So see, frequency will again be 1.1 into 10 to the power 3 hertz. 2n minus 1, we don't know, divided by 4l. L will be 30 centimeters. And then the velocity will be 330 meter per second. This is the data. Now see, 2n minus 1, we can write it as 1.1 into 10 to the power 3 into 4 into 30 into 10 to the power minus 2. Just have cross multiplied and this comes in the denominator. This is 330. See, 0, 0 will get cancelled. 3 multiplied by 11 would give, and 11 into 0.1 will give. So this means this is 10 to the power minus 1. 10 to the power minus 1 and 10 to the power minus 2 gives 10 to the power minus 3. So 10 to the power positive 3 and 10 to the power negative 3 gives 0. So we are left with only 4. So 2n minus 1 is 4. So we have to find out 2n is equal to what? 4 plus what? So see, 2n will be equal to 5 and n will be equal to 2.5. Are we getting 2 here?
No.
See, for resonance, both should match. So it means this closed organ pipe will not be giving frequency of 1.1 kilohertz. If we change the frequency, then only this n will change. So this means this cannot give 1.1 kilohertz of frequency. Understood?
Yes, ma'am.
Okay, so note this down.
Ma'am, can you scroll? Done, ma'am.
So is this clear? Any queries, any doubts up till now?
No, ma'am.
Oh. Let's do few more questions. Hishma, go. See, it says an open organ pipe is suddenly closed at one end, with the result that frequency of the third harmonic is found to be higher by how much? 100 hertz than the fundamental frequency of an open pipe. Just a second. Yes, okay. So see, it says an open organ pipe is suddenly closed at one end, with the result that frequency of the third harmonic is found to be higher by 100 hertz than the fundamental frequency of open organ pipe. So we have to find out what is the fundamental frequency of this open organ pipe. And velocity of air is also provided to us, that is 330 meter per second, like the previous question. See, before moving further, the frequency of an open organ pipe. Again, I'm repeating. This is given by V by 2L, and the frequency for a closed organ pipe. This is given by 2n minus 1, the velocity times the velocity by not twice the length, but 4 times the length. Okay. Now see, for the third harmonic. Okay, can you tell me for the third harmonic, which overtone is this?
Second.
Second overtone. So see, n will be equal to 2. This gives us the third harmonic. Now see, if we put n value, then the frequency for the second one we'll be getting as 2 into 2 minus 1 times the velocity divided by 4 times the length. So this gives 3v by 4l. And we have already seen 3v by 4l. I think you have written also in your notes. So 3v by 4l is covered. Now see, for an open organ pipe, it's v by 2l. For this is for the 2. This is frequency first for the open pipe, and second one for the closed organ pipe is 3v by 4l. Now see, the question says frequency of the closed one for n equals to 2. This is the sum of the frequency of open organ pipe by 100 by C. See, the question says that an open organ pipe is suddenly closed at one end, with the result that frequency of third harmonic is found to be higher by how much? 100 hertz. If it is found higher by 100 hertz than the fundamental frequency of open organ pipe, it means whatever is the frequency of open organ pipe, if we'll add 100, will we be getting the closed one? See, closed organ pipe is what? This is found to be, the frequency is found higher by how much? By the open organ pipe's frequency. So if we add this, if we add the greater amount, that is 100, to this open organ pipe's frequency, will we be getting the frequency of this closed pipe?
Yes,
Yes, so that's what I've written over right. That the frequency of this closed organ pipe, this is found to be 100 hertz higher than this open organ pipe. So if we combine this will give us the closed one. Now see, we don't have any direct relation for these, but we have these relations. So what we can do one thing is that we can take the ratio of these so as to establish a relation between these two. So see, if I take the ratio between frequency for the open one and the frequency second one for the closed one, this will be giving us velocity divided by 2L for the open one and 4L divided by the velocity, and 3 will also come. So velocity will get cancelled, length will get cancelled, 2 multiplied by 2 will give us 4. So see, now we can say frequency of open organ pipe is 2 by 3 times the frequency of closed organ pipe. Now see, you have this equation 1, you have this equation 2. Two equations are there and two variables are there. Are these sufficient for the calculation of both of these?
Yes.
Yes. So see, let us take what is the value of the closed one. It will be 3 by 2 times the frequency of the open pipe. Now see, when we put it in the main equation, instead of closed, I'll be writing 3 by 2 frequency of the open. This gives us the frequency of the open plus 100. See, this was the equation that we had derived. Frequency for the closed one was frequency for the open one plus 100. So I can put the value of closed one in terms of open organ pipe. Now see, let me take it to this left hand side. Minus frequency of the open organ pipe, this gives 100. See, 3 by 2 minus this frequency of open organ pipe, this will give half simply. 3 minus 2 is 1, 1 by 2 is half. So this gives frequency of open organ pipe divided by 2 into 100. So what is the frequency of open organ pipe?
200.
200. That's what we had to calculate. What is the frequency of the open organ pipe? Is it clear? See what we have done. We have seen what we have just established the relation between these two so as to get an equation. And also rest of this equation, like this equation was already given in the question in terms of words. And we had to calculate what is the fundamental frequency of open pipe. Had it asked us the frequency of closed organ pipe, then we would have substituted it. We would have substituted the value of open organ pipe in this, and we would have got the value of the closed organ pipe. So see, if open organ pipe is 200, what should be the frequency of the closed pipe?
100.
100. See, this is 100 times higher than the open one. Look at this equation. If we have to find out this, and this is 200. The frequency of closed organ pipe will be
300.
300. So had it asked us, you could have done. Right.
Man, can you scroll? Don't know.
See, the next question says that the first overtone of an open organ pipe. Okay, first overtone. So what is the value of n?
1.
1. If n is equal to 1, then that is the fundamental. And we don't have any overtone for the fundamental. First overtone, not first overtone means n equals to 2. See, for the second harmonic motion only, we get first overtone, no? Then for the third harmonic, we have second overtone. Then for the fourth harmonic, we have the third overtone. So if it says first overtone, then which harmonic it is?
Second.
Second one. All right. Then it says it beats with the first overtone of closed organ pipe. And the beat frequency is given. This beat frequency is given for which one? This is for the open organ pipe. And the fundamental frequency of closed organ pipe is 110 Hz. And we have to find out the length of the pipe. So we have to find out the length of the closed organ pipe as well as the open organ pipe. Now see, for the closed organ pipe, if I tell you, since it is given fundamental frequency, then what should be the value of n? Fundamental frequency.
1.
1. N will be equal to 1. See, first one is the fundamental frequency, that is the first harmonic. First harmonic is fundamental. Then we have n equals to 2, that is the second harmonic and first overtone. Then we have n equal to 3, third harmonic or second overtone, and so on. Is this clear?
Yes, ma'am.
Okay. So see, fundamental frequency of closed organ pipe, this is 110 Hertz. This is 110 Hertz here. And speed of sound in air is also given to us as 330 meter per second. So see, frequency of the closed organ pipe for the first one, for the fundamental, is given by V by 4L. Yes, that's what we have seen. So we have to find the length of the pipe. Length, let's say LC should represent the length of the closed pipe. So LC will be equal to what? Velocity divided by 4 times the frequency of the fundamental frequency of the closed organ pipe. Now see, we have all the values for this, for the calculation of this. Length of the closed organ pipe should be velocity of sound in air is 334 multiplied by, what is this value? Fundamental frequency of closed organ pipe. What is this value?
2n minus 1 V by 4n.
No, this is given in the question. Fundamental frequency of closed organ pipe.
110.
110. It's already given to us. This is 110. So 0 will get cancelled. This will be 3. So length of the closed organ pipe will be 3 by 4 meters, which is 0.75 meters. So length of closed organ pipe is what? 0.7 meters. This part is clear, the calculation of length of closed organ pipe?
Yes, ma'am.
Okay. Now see, it says that, I scroll it up, look at the question. It says this first overtone for this closed organ pipe, this is beating with what? Open organ pipes, first overtone with frequency 2.2 Hertz. So first overtone of open organ pipe. First overtone means n is equal to what? 2. And for the value of frequency, we have 2n minus 1 multiplied by the velocity times 4 of length of what? Closed organ pipe, because this is the formula for closed organ pipe. Now see, for the second frequency of second one will be for the closed pipe. This will be 2 into 2 minus 1 divided by 4 times the length. This is 4 minus 1 is 3. This gives us 3V divided by 4 times length of the closed pipe. So now see, for the calculation of frequency of the second part, of the second overtone, 3 into 330 divided by 4 into length of the closed pipe is 3 divided by 4. So this gets cancelled, 4 gets cancelled. Frequency of the closed organ pipe for the first overtone is 330 Hertz. The frequency is clear?
Yes, ma'am.
So see, this frequency will be the same for the open organ pipe that is given. Look, it says this first overtone of open organ pipe. This is beating with this frequency for what? First overtone of closed organ pipe. Now see, for an open pipe, this was regarding, everything was regarding closed organ pipe. Now see, if we write everything for open pipe, again, we have to calculate it for the first overtone only, and first overtone means n is equal to 2. So frequency n, this is given by nv divided by 2 times the length of the open organ pipe. So see, frequency of the open organ pipe for the second harmonic or the first overtone is given by n is equal to 2 times the velocity by 2 divided by length. So 2 will get cancelled, and frequency of open organ pipe for the second one. Second one means the first overtone. This will come out to be velocity divided by the length of the tube of open organ pipe. All right?
Yes, ma'am.
So now we have to substitute all the values. Now see, See, this says that these are beating with, means the first overtone of open organ pipe. This beats with first overtone of closed organ pipe. And what is the beat frequency? Beat frequency is 2.2 hertz. It means the difference of these frequencies. That is the difference of the closed organ pipes frequency and the open organ pipes frequency. This gives the beat frequency. So see, what is the value of the closed organ pipe second frequency? 330 that we have calculated. Minus for the open organ pipe is V by L naught. V will be 330. Length of open organ pipe, we don't know. And beat frequency is given as 2.2 hertz. Now from here, will we be able to calculate length of the open pipe?
Yes.
Okay, this was only missing, no? We have calculated the length of the closed pipe. So see, this will be 330 minus 2.2. This will give 330 divided by L naught. So L naught will be 330 hertz divided by 327.8. So this is approximately, it will come out to be 1 meter only. No, see, the difference is very less. So it will be 0.99 something. That will come near to length is 1 meter. So length of open organ pipe will be 1 meter. And the length of the closed pipe will be 0.75 meters. Clear?
Yes, ma'am. Ma'am, can you start?
Now see, the next question says that a well with vertical sides and water at the bottom resonate at 7 hertz. This is the frequency given. The air in the well has density and the bulk modulus respectively. This is given. The bulk modulus is given and the density is given. So bulk modulus, do you remember we have done bulk modulus when we were discussing mechanical properties of solids?
Yes.
Yes. So see, this relation you might not be knowing. Velocity of this, velocity of air, bulk modulus and density has a relation. This is under root b by rho. See, velocity is what? V is the speed of sound in air or wherever, whatever medium, just the speed of sound. In air, it can be in air or any other medium. B is the bulk modulus and rho is the density. B is the bulk modulus and rho is the density. Now see, it has given us frequency and with vertical sides and water at the bottom. So the frequency is given by what? Velocity divided by 4L. And length, we have to actually calculate the length of the pipe. Consider this well as a pipe. Then we have to actually find out the length, no? Because it asks us what? How deep is the word, not word. How deep is the well? How deep is the well? So if it asks us for how deep is the well, it means we have to find out its length. So length will be what? Length will be simply velocity divided by 4L. And what is velocity? Velocity is under root b by rho. And here we have 1 by 4 times the frequency. Okay, see, this is the relation you already know. For calculation of length, we will be writing velocity by 4 times the frequency. For the velocity, because since the velocity is not given to us, but we have the sufficient data of density and the bulk modulus. And this is the relation. So if we put the value of bulk modulus and density's relation in terms of velocity, will we be getting length is equal to under root b by rho 1 by 4 nu?
Yes.
So see, you have all the data sufficient with you. Try this question now. See what's the length coming. Take 2 minutes. Write all the values. The density is also given. The bulk modulus is also given. I'll scroll it up so that you can see the question. And the frequency is also given. This is 7 hertz. This is 1.1. See what's the length coming.
$12.4 meters.
How much? 12.4 meters, yes. 12.2 or 12.4 meters. It should be 12.2, I think. So this is also right. It will be 12.4 meters. So this is clear to you? How have we calculated the length of the well? Okay, let's see more. Okay, see. See, this says that the velocity of sound in an open end is 330 meter per second. Frequency is given as 1.1 kilohertz. And the length of the tube is 30 centimeter. We have to find out the harmonic that it will emit. Okay, before this, let's do one more thing. An organ pipe open at one end is vibrating in first overtone and in resonance with another pipe open at both ends. And this is vibrating at the third harmonic. We have to find out the ratio of length of the two pipes. See, if I give you the options, A is 1:2, B is 4:1, C is 8:3, D is 3:8. This is the question. So see, what does it say? It says an open organ pipe. An organ pipe that is open at one end is vibrating in first overtone. So if it is open at one end, what kind of organ pipe is this?
Closed organ pipe.
Closed organ pipe, yes. So let's say the frequency of closed organ pipe. Now we have to identify what is the value of N. So it says this organ pipe open at one end means a closed organ pipe. This is vibrating in first overtone. So what is the value of N? First overtone.
2.
2. N will be equal to 2. This is vibrating in resonance, means the frequency is same with another pipe open at both the ends. Now what kind of pipe is this which is open at both the ends?
Open organ pipe.
Open organ pipe. The frequency is same with the open organ pipe. And the third harmonic means N equals to 2. See, third harmonic means what? Which overtone?
Second.
Second overtone. So we have to find it for the third one. N is equal to 3 is for the third one. Okay, now see the values of the frequencies. See, this is 2n-1 V by 4L for the closed organ pipe, and for the open organ pipe, it's N V by 2L. Now see, length of the pipes are different, which we have to find out. Length of closed organ pipe and length of open organ pipe. See, velocity is same, velocity will get cancelled. You have the value of N with you. N for this is 2 and value of N for open organ pipe is 3. So put it in this equation, see what is the ratio coming. What is LC divided by LO coming? Just check it once.
1/2.
Yes, 1/2. So which option is right?
A.
A option is right. So this was easy, clear, understood?
Yes, ma'am.
Okay, now let's see the question. See, velocity of sound in an open organ pipe, open end is 330 meter per second and the frequency is 1.1 kilohertz. And the length of the tube is given, we have to find out the value of n. So this is also very easy. Frequency for nth mode is nv divided by 2l. Okay, now see, frequency for this open end is given what, 1.1 kilohertz. This is into 10 to the power 3 hertz. Okay, n we don't know. Velocity is given 300 meter per second. Length of the tube is 30 centimeters. So even I think you don't even need to calculate much. Just check what is the value of n coming out of all the options. Which answer is right? We just have to find out n.
Four.
N is coming out to be 4. Let's see. See, we have to find out n. N is given by 2l into frequency divided by the velocity. This is 2. Length is 330 into 10 to the power minus 2. Frequency is 1.1 into 10 to the power 3 by the velocity is 330. See, 0, 0 will get cancelled. 3 multiplied by 1 is 3 and 3 multiplied by 11 is 33. Now see, 11 multiplied by 1 gives us 11 and 11 multiplied by 0 point gives us 1.1. Now see, this is what? This is 2 into 10 to the power minus, this is 10 to the power 3. This is what? 10 to the power minus 2 into 10 to the power minus 1. This is 10 to the power minus 3. 10 to the power positive 3 gets cancelled and negative 1. N is equal to 2. Okay. So it would be A option. Where did you commit the error? In this part?
Yes, ma'am. Calculation.
Okay, just note it down.
Done, ma'am.
Let's just see one last question. See, the frequency of vibrating air column in closed organ pipe is N. So frequency of closed organ pipe is N. So if the general formula of frequency is what? For closed organ pipe, this is 2n minus 1 times the velocity by 4L. So this is given as N. Okay, see, this can be confusing with this N. Let us take this N as M for the meanwhile. Okay, this is that only that we take N. Since the question is saying this is N, I am writing this as M. I hope you are understanding what is this M.
Yes, ma'am.
Yes, this is this N only that we write in the formula, just in order to differentiate between the frequency and number of vibrations, number of mode of vibration. I have written it as M. Otherwise, it's the same formula. Now see what it says. It says if its length and radius both are halved. No. Length is doubled and the radius gets halved. What should be the frequency? So let's say n dash is the new frequency. 2m minus 1. This for the general formula. Velocity is remaining the same. What change has occurred? Length has been doubled. So 4 times double the length. So just take out the ratio. See which option is matching.
Two N.
Which one? Which option? A, B, C, D?
C.
C twice N. C. It won't be twice of it. Just look at this. Even without taking the ratio. If you leave this 2L, look at all these terms. Apart from this 2L. All these terms are what? Aren't they this? Yes. See 2m minus 1 v by 4L. 2m minus 1 v by 4L. Yes, Asifa?
Yes.
So see n dash is what? This is n by what is extra? 2. So this is n by 2, not 2n. See, even if you take the ratio, n is what? 2m minus 1 by 4L. And n dash is what? 4 into 2L by 2m minus 1. And the velocities obviously. So velocities are getting cancelled. 2m minus 1 are getting cancelled. 4L is getting cancelled. So what is left? N is equal to twice of the new frequency. But we have to find out n dash. N dash will be what? Half of the original frequency. Understood? What was the error that you did? How did it?
I was saying the value of N instead of
N
N
dash.
dash.
You have calculated this. Okay. Fine, noted down.
Done, ma'am.
Okay, so we have then at least 6 to 7 questions. I hope this topic is clear. Organ 5, closed organ.
Yes.
Any doubts from this?
No, ma'am.
Okay. Now see, we have one last topic, that is Doppler's effect. But this Doppler's effect is now I don't think so. I don't think so. It's a part of the syllabus now. But let's just discuss it in brief. So see, the definition says that the apparent change in the observed frequency of a wave due to the relative motion between the source and the observer. The source is where from the wave is generating, and the observer is the recipient, which is receiving the waves. So this change is observed because of the relative motion, and this change is known as the Doppler's effect. This is called as the Doppler's effect. Now see, the Doppler's effect occurs when a source of waves moves relative to the observer. If I say this is the source, this is the observer. The source is emitting waves. Now see, so Doppler's effect occurs when a source moves relative to the observer. See, you are familiar with rise and subsequent drop of horn as it approaches and passes. When we are near to the horn, we can hear it loud. So you are already familiar with this rise and the drop in pitch of automobile horn as it approaches and then it passes. So what is this? That is the frequency of sound is raised when the source of sound approaches you, and lowered when the source is moving away from you. Right or not? When the frequency of sound is raised. When it is raised? When it is near to you or when it is far away from you? Near to you. And then this frequency of sound is lowered when the source is moving away from you. So the reason is simple. As the car, let's say this is the car, as the car approaches a stationary listener, let's say this is at rest. So as the car approaches a stationary listener, the sound waves are crowded together. All the sound waves get crowded together. So what happens? As the car approaches, the sound waves are crowded together. This causes a decrease in wavelength. And when the wavelength gets decreased, what happens to frequency?
It increases.
It increases. That's why the frequency gets increased. Now see, after the car has passed and moving away from the listener, means this case, if this is the observer now, this is the source and this is moving away. This was approaching it. Now it is moving away from it. So as the car has passed and is moving away from the listener, the sound waves are now spread out. The sound waves are spread out like this. So as a result, what happens? The wavelength, see this wavelength between the waves increases. So what should happen on the frequency? If wavelength increases, what effect should it have on frequency?
Frequency will
Decrease. So that's why whenever a source of sound approaches the observer hears it with a greater frequency. And whenever the source of sound is moving away from the observer, the frequency gets reduced. I'll write it down in words also. See, if source and observer move towards each other, then apparent frequency increases or decreases?
increases.
Increase. It will increase. And see, if source and observer move far away from each other, then what effect should it have on the apparent frequency?
It decreases.
It decreases. This frequency decreases. So are you able to see this change in frequency because of the relative motion between source and the observer? This effect is known as Doppler's effect. So is this definition clear what I have written this? This definition, this apparent change in frequency due to what? The relative motion between a source and an observer. This is called as Doppler's effect. Fine?
Yes.
Okay. Now see, just remember this formula as well. A few terms before writing down the formula. Nu naught will represent the true frequency. Now see, what is meant by true frequency? True frequency is the actual sound emitted. See, because of the relative motion, we are not able to hear the exact sound. Sometimes we are able to hear it with a higher frequency and sometimes we are able to observe it with a lower frequency. But the true actual frequency that has been emitted by the source. Actual frequency emitted by the source. This is the true frequency of sound. So let's say it is represented by nu naught. Then we have V. V is the velocity of sound, speed of sound. Then we have VO. V naught is velocity of the observer. See, if the observer is at rest, you can take the velocity of the observer as 0. If the observer is moving with some respective velocity, then you can equate the value and this. So V naught represents the velocity of observer. And then the frequency is the actual frequency, apparent frequency observed. Nu naught was the true frequency. Only nu without any representation, any subscript. This represents the apparent frequency of the sound emitted or observed.
Observed.
Observed, right, correct, observed. And Vs will be representing this velocity of the source. So the final formula for the apparent frequency heard, this is V minus V naught divided by V minus Vs, this whole term multiplied by the frequency. This is the formula. But see, we use a sign convention over this side. A sign convention has to be used. Which you have to substitute it for every question if you get. I think this will come in your entrance only because this is not a part of your board exams. So for sign convention, you should remember that from source to the observer, this is taken as positive. And from the observer to source, this is taken as negative. This is the sign convention. So if this is source, if source is moving towards the observer, then you can take it as positive. This is for the medium at rest. Medium is not moving. Medium is at rest. If medium also moves, then we have to add one more component. So it means this, what is meant by this? What I've written, source to observer. This means if this is the source, this is the observer, and the source is moving like this. So and let's say observer is moving in this direction. Okay, let's just take an example. So source to observer is taken as positive. Source to observer means this direction becomes positive. So tell me, velocity of source, will it be positive or negative? This direction is positive right now. Why? Because source to observer is positive. So velocity of this will be
Positive.
positive. And velocity of observer will be?
Negative.
Why will it be negative?
Positive.
It will be positive or negative?
Positive.
Why? Why positive?
Because it's in the same direction.
This observer is moving in this left hand side.
Oh, the negative.
Negative. It will be negative. See, that's what I was telling you. Okay, let's take another example. Let me get that clearer. If this is the source is moving in this direction. Observer is moving in this direction. Source to observer is taken positive always. So it means source is there, observer is here. It means this direction is taken as positive. So it means what? From source to observer is positive. If this direction is positive, velocity of source will be positive or negative?
Negative.
Negative. And velocity of observer?
Positive.
Positive. Clear? Taking the
Yes.
sign convention? Okay, then let's do just a single question. I think you should note it down.
Nothing. Ma'am, can you screen? Done, ma'am.
Okay, just let us see one question so that you understand how to apply this formula that we have seen. So see, if I say this, there's a car, it is emitting frequency of 100 hertz. So this is the true frequency or the apparent frequency?
Apparent frequency.
The car is emitting this frequency.
True frequency.
True frequency, no? The apparent frequency is one with regard the relative motion. See, and then if I say there is another car, this frequency of this car, I don't know. We have to find out the frequency of this. But see, if I say this car is moving towards it, this is moving with 10 meters per second. This is the source. And this is the observer. And the observer is moving with 5 meters per second. And the velocity of means the speed of sound. This is given to us as 300 meters per second. So at least just draw this, then we'll discuss. Just at least write down, then we'll discuss. Written, shall we discuss?
Yes, ma'am.
Okay, see. So this is the source and this is the observer. So from left to right, should I take it as positive, or from right to left, should I take it as positive?
Left to right.
Left to right, because source to observer is taken as positive. So we have the sign convention ready with us. See, it could have been reversed. It means this is not necessary that the source is placed on the left hand side only. Observer can be here and source can be here. What you just have to see the direction. If this is moving like this, so now in this case, from the right hand side to left hand side becomes positive. So you have to check it with regarding their direction, not source is kept left or right. All right. Now see, so velocity of source. So velocity of source will be plus 10 meter per second or minus 10 meter per second?
Plus 10.
Plus 10 meter per second. And the velocity of the observer. Velocity of the observer plus 5 meter per second or minus 5 meter per second? What?
Minus 5.
Minus 5. Minus 5 meter per second. All right. And the speed of sound is taken positive only. And the frequency of the true frequency is given 100 and we have to find out the apparent frequency. So we have the relation V minus V naught by V minus Vs multiplied by the frequency. So just we have to substitute all the values. See, V is 330, no, 300. 300 given, velocity is 300 given, minus. Now for the observer, should I write minus 5 or plus 5?
Minus 5.
Minus 5, this will be, this negative sign is of the formula, this negative sign is of the sign convention. By velocity is again 300 minus velocity of the source is 10. This whole multiplied by the frequency. Let us take it as 1000. Take this as 1000. Just change it, edit it in your question, what you have noted. Multiplied by 1000. So the frequency will be 305 divided by 290 into 1000. Now see, this will always come, this difference will be very less every time when you calculate. So you don't have to approximate this. Whenever you are calculating, doing calculations of Doppler's effect, never round off all the terms that are given. Otherwise, this frequency will come whatever is the original frequency only. So once you multiply this will come around 1051 Hertz. Understood?
Yes, sir.
Okay, just note down the solution as well. And please make it 1000 Hertz.
Done.
Completed?